Today we will be covering chapter 1.8 from unit 1, and that is titled Pressure. Huh? Why is it giving me the eraser? Huh. Switch to syllabus. Pressure. Okay, now we've been talking about forces all through
Sir, you're not sharing your whiteboard.
uh, knowledge. Now, can you see it?
Yeah.
So we've been talking about forces throughout unit 1, and forces act on objects. They change direction, they cause the velocity to change, they cause a turning effect, right? They cause energy transfers, momentum, all of that, right? Work is done. But there's one thing to consider, that forces, when they act on objects, they act when forces are acting on objects, right? They act on a certain area, right? For example,
Yeah.
your body weight when you are standing, where is it acting?
Downwards, like.
Yes, but what part of the body is it acting?
Repeat that.
What part of your body is your body weight acting on when you are standing?
Feet.
Your feet,
Yeah.
right? What about when you're sitting?
Uh, on.
Your hips.
Yeah.
And when you're lying down,
On your back.
right? On your back. Now, in terms of area, which three of these have the least area?
Least.
Least area. The method.
Feet.
Yeah. This is least. Your hips perhaps are equal
Second.
or more, right? So these are somewhere in between. So more area than the feet. And when you're lying down, right, your back is obviously covering the most area.
Yeah.
Now, in all three situations, right, what's the force that is acting is your body weight, right? So that is obviously your mass. For example, you're 60 kgs, and so into 10, which is G, and so that's a 600 Newton force. And so you've got
Yeah.
600 Newton force acting on your feet, and let's say your feet are like uh, 30 centimeters, so that's right 0.3 meters, right? And so 0.3 square, let's take it as your feet are square, right? That's 0.09. Your hips are covering more area, so 0.5 perhaps, and so that would be 0.25 meters squared. Is that correct? 0.025. Yeah, 0.25. Okay. And then your back is, let's say it's 1 meter, right? So that is 1 meter square. So, right, the area, this is the least area, this is somewhere in between, this is the most area. And so you've got the same force acting over three different areas depending on your posture or your physical position. Pressure is force acting per unit area, right? And so the formula for that is P equals to F of A. Right, where force is obviously in newtons and right area is in meter squared, so pressure is in newton per meter squared. Okay, now how is this relevant? Well, right, if you have, right, again taking this example, right, what's your pressure in this case? So let's take 600 divided by 0.09, and that would give us what?
That would give us, wait, 666. Like there are four six
Yeah, 6,666.67.
point six. Yeah.
So 6,667. Oh, by the way, right? The SI unit for pressure is Pascal,
P.
right?
Oh, okay.
PA, right? So
Okay.
you've got that much pressure. Then you do the same for when you are sitting. So 600 divided by 0.25, and that would give you
Mm,
20,
24,000.
2,400.
Yeah. Sorry.
So obviously very less comparatively, significantly
Yeah.
less. And then 600 divided by 1, which is obviously 600.
Yeah.
And so, right, when the same, when the force is acting on a smaller area, there is higher pressure, right? Lesser area, sorry, more area, and then even more area comparatively. And so you can see the pressure, right, is going down. So you can see that relationship. So pressure, right, is directly proportional to the force. So the higher the force applied, the more the force applied, the more the pressure, but it is inversely proportional to the area. So the lesser the area, the more the pressure. The more the area, even for the same force, as we just done these calculations, same force applied over a larger area reduces the pressure. How does that, apply in the real world? Why does it matter? So a situation such as a tractor, right? Have you ever seen a tractor
Yeah.
in real life?
Yeah.
Okay, so a tractor is a big machine, right? And so this is a heavy machine. And I'm not going to draw that because obviously my drawing skills are, primary student has better drawing skills than myself. But point is, right, a tractor has big wheels, like a monster truck. And those, they're not only big, but they're also wide,
Yeah.
right? And so what those wide wheels do is that, right,
They cover up more area.
exactly, and there's four of them, right? So the wide wheels of the tractor, there's four of them, so there's more area, and so the weight of the tractor, and obviously it's a heavy machine, becomes distributed, right? And so that prevents it, and that actually enables it to move on soft soil, because tractors are, for example, used in farmlands, right? And so the soil over there is soft, it's not hard ground.
Yeah.
Why? Because that weight, so the pressure is less. So the force over the area is distributed, and so there's no point force acting at a single point. If that were the case, for example, right, you Like, is it easy to uh, plant a stick into soft soil? Like you're at the beach,
Yeah.
right? You take a stick, you poke it into the sand, it goes in easily,
Yeah.
right?
Yeah.
Or for example, let's take your body weight example again. You're at the beach. When you're standing, you see the impressions, right? Sometimes your feet even sink a bit when
Yeah.
the sand is rather wet because it's
Yeah.
soft. But if you're sitting, you don't see the same. You're not sinking when you're sitting. When you're lying down at the beach, you don't
Yeah.
sink in. But right, it's difficult to walk because your feet are sinking into the sand. Why? Because when you're standing and walking, with each step, right, you are applying, right, with each foot, you're applying that much pressure, and so at one point, right, there's more force, and so your feet are sinking into the sand, right, as opposed to when you are sitting or lying down. So that is the general concept. Does that make sense? Now,
Yes.
right, the tractor is one practical application. Another one that they've mentioned, which I don't think, well, I haven't experienced at least. Have you gone skiing? Hmm?
Sorry?
Have you gone skiing?
No.
No. Well, have you seen skis?
Yes.
Right? And so they're these long, right, equipment. And so the foot is placed over here somewhere in the middle, I guess. Right? So that's supposed to be a foot. Now, what happens, right? Normally, you would be exerting this much pressure with your feet directly. But now, right, let's say this is 1 meter. And so, right, your weight is being distributed over the ski. And so instead of pressure of 6,667 pascals, you are now only exerting a pressure of 600 pascals because I said the ski is 1 meter, right? And so the area has increased, your body weight has not changed, right? The area over which your body weight is acting has increased because of the ski, right?
Yeah.
And so that, right, there's less force per unit area. And so, right, you don't like your feet don't sink into the soft snow. And
Yeah.
a different example is a nail, right? Nails are sharp and pointy, and then you hit it on the head with a hammer, the head of the nail, right? And so the tip of the nail is like maybe um, you know 2 millimeters. So that's 2 into 10 to the power -6 meters. Okay. Sorry, -3. That would -6 would be a micrometer. So -3, right? And then you're hitting it with a hammer, and so right, maybe you're hitting it with the force of 1,000 newtons. And so what's the pressure? Right? The pressure at the tip of the nail would be what would we get? 0.002.
Just.
That is 500,000 pascals.
Yeah. Yeah.
That is a lot of pressure, and that's why, right, when you hammer a nail, depending on if you're putting it into the wall or furniture, so wood, That's why it's easy to penetrate, right? You hit something flat with the hammer, it will put a dent, but it won't penetrate into the wall, it won't penetrate. Or even if you hit, the hammer without the nail on your furniture, it will obviously cause damage, so don't do that, right? But if you hit the hammer, so right, obviously this surface of the hammer head has more area, right, as compared to the nail. The nail is just, right, that dot over there. And so if you hit the hammer on the wall or the furniture directly, it will not penetrate the wall. Why? Because the pressure is less, because there's more area over which, right? So over here, your kinetic energy from the movement of the hammer is being transferred to the head of the nail, which is being transferred to the point, right? The pressure is being transferred, and then the nail is being driven into the wall or the furniture, right? And so having less area increases the pressure, and that basically allows for, right, uh,
Mm.
yeah, the nail to go in.
Yeah.
That makes sense,
Yeah.
right? So generally, that's how pressure is applied and how it's useful. Now, what else do they tell us? I've done a few examples of my own. So there's a work example and some questions in the text. You can take a look at them. Now what they talk about, right? So that's as much as they talk about pressure in general. Then there's more focus on pressures in liquids, the liquid pressure. Now the concept is the same, but they'll come to the math later. Right now they're just giving you certain
Yeah.
bits of information about it. So the first thing they tell you is, just a bit, the pressure. So the first point is the pressure liquids increases with the depth of how deep the liquid is. Why is that? Because the more the depth, right? So the more the column of water above, which means the more the weight of the liquid, right? And we also know that weight is a force. And we just learned that pressure is force upon area, right? So the deeper you are in the liquid, or the greater the depth of the liquid, the greater the pressure experienced at that depth. So when you're diving in the sea or in a pool, right, the deeper you go into the sea, the more pressure you will feel.
Yeah.
Okay,
Yep.
because the weight of, right, and this is just about depth. It's not about if you're diving in the sea, oh, the sea is so vast. The vastness doesn't matter. The depth, it's only the depth. Let's say the height of the column of, the height of column of liquid. Okay, then the second point they make is the pressure at a certain depth, right, acts equally in all directions. And the explanation they give for that is that they give you two diagrams. One, right, is a container filled with water, and it has holes at 3 different depths, right? So top, bottom, and the middle. And what they say is, right, the pressure at the top is going to be the least based on, the first point they've given. And so the water coming out will be something like this. From the second one, it will be going slightly further. From the third one, it will go the farthest. Why? Because, right, the pressure increases. So that's for point one. Now, the second illustration they give is that they give a bucket. And what they do is that they make holes at a certain depth equally. And so what happens is that from any one of these holes, right, because it's filled with water and all these holes are at the same level, the water that will be spurting out with the same force, right? It will be going the same distance. Obviously, it doesn't make much sense with the drawing I've made. Hopefully, the verbal explanation helps. And this is perhaps something that you can try. You'll have to sacrifice a container, right? You can take a plastic container, make some holes in it, and then try this out.
Yeah.
Okay. And because, right, the water is, the pressure is acting downwards, because, right, this is the area at this point, and this is the height. So the pressure is, right, the force is acting downwards, the pressure is, right, and so the water is coming out horizontally. So one thing they mention is that the water emerges horizontally and normal to the surface of the container, showing that the pressure produces a force in a direction at right angles to the surface. So basically, right, pressure downwards, force downwards, right, that causes the water to move out horizontally, which is at normal. Normal in this case means 90 degrees, right? So this is the pressure, the force, and the water is moving out horizontally. So it is at a norm 90 degrees.
Okay.
Okay.
Yeah.
Now it's the same over here as well. So the top hole over here. It's just that it's not traveling very far, and so just like plops fall down. Right, gravity is affecting the water. So as soon as the water starts coming out, if it's not under a lot of pressure, it won't go very far. It very quickly, bends and falls to the ground. Okay,
Yeah.
but the same
Yeah.
concept of the normal applies over here as well. The third point that they make is what they call liquids. A liquid finds its own level. And what they do for this, I'll use this space for the illustration. And right, so what they do is that they show an apparatus. And so there's like right, as you can see, one arm of the tube is thin, the other arm of the tube is wide.
Yeah.
And initially, what you have is that you've got, right, water at a higher level in the thin tube and water at a lower level in the wider tube. And let's talk about the bottom, right? So at this point, in which arm of these tubes, the thin one or the wide one, is there more pressure?
Mm. I think it would be the thin one
Why?
because it has more water in it.
The depth or the height
Yeah.
of the column
Yeah.
liquid,
Yeah.
right? So there's the height of the column of the liquid is more, right? And so there's more pressure on this side, right? You would say, right, oh, well, it's wider. Well, that actually reduces, right? Not only is the height of the column of the liquid, the area over which it's acting is also greater. So that will also reduce the pressure, right?
Yeah.
And so what would happen is, right, if you let water, so this part of the tube is stopping water from flowing, right? If you allow the water to flow, what you will notice is it will balance out.
Yeah.
Right, higher pressure over here, lower pressure over here, this, the level of this liquid will move down, the level of this liquid will have moved up, and so it balances out. And that's what they mean by a liquid finds its own level.
Yeah.
And
Okay.
right, unfortunately I haven't looked up any videos for this, but you can search this on YouTube and find some videos, and I'll look something up after class and I'll share that on the group.
Okay.
Okay,
Yeah.
any questions?
No.
Then lastly, pressure depends on the density of the liquid. So not only does it depend on the depth, but also the density. Right. So this makes sense.
As in, the more the dense, the more pressure it is.
Exactly. Right. The greater the density, the more the
Okay.
pressure. Right. And you add then the depth. So the greater the depth with the density, the more the pressure, and all those factors. All right.
Yeah. Yeah.
Then they talk about. Okay, so we're done with these 4 points. Okay, I'm putting an asterisk, although it is, it's not a side topic. We talk about the water supply system, and so the main water supply system for towns or villages or even cities is usually made right up in mountainous regions. So dams are made right, or reservoirs of water are made in mountainous regions. Why? Because they're high up, and the higher up they are, right, point number one applies. When they are supplied to the city or the town, they move down, right? And the lower the right a point of supply is, the more pressure it will have, right? So, for example, you're in an apartment building, right, and you've got the water tank on the roof, right?
Yeah.
The first floor or the ground floor tap will have water with highest pressure. So they'll have a good pressure of water in their taps. Right? The higher up you go in the building, the less pressure it will be. Why? Because the distance between the water supply, the tank or the reservoir of the building, and the floor and the tap is less. And so, right, the lesser the distance between the supply and the outlet, right, point number one, the lesser the height, the lesser the pressure. So in this case, right, the people in the lower floors actually have better water supply in terms of pressure,
Okay.
right? Okay.
Yeah.
Now we're coming to a topic about hydraulic machines. Now this topic is not part of the O-level syllabus. It's given in your textbook, in the O-level textbook, but as a going further topic. However, it is part of your IGCSE syllabus. I have to cover that. So hydraulic liquid, hydraulic machine, sorry. Right? They make use of liquids. And the fact that liquids are nearly incompressible. What does incompressible mean? It means they cannot be squeezed into smaller spaces,
Okay.
right? So you can't apply force on a liquid and make it, fit into a smaller container. You can't do that, right?
Yeah.
And right, secondly, they transfer any pressure applied on them. So the setup is, right, some you've got so what you have over here, right, this is a piston. This is what will be compressed or raised, right? And for example, you have something heavy over here that you want to lift up. So this is a load, right? Now, if you're going to directly try and lift it up, it's going to be difficult because it's a load, it's heavy, right? You've got liquid in here, right? In case of hydraulic machines, they use oils, right?
Yeah.
And so they're applying a small force F, and that is causing a larger force on the other side. How does that work? Well, the area is also smaller here, and the area over here is larger, right? And we know pressure is force upon area. So in this case, P equals to small f over small a, right?
Yeah. Yeah.
Acha. Now, right, they transfer any pressure. So whatever pressure is being formed over here, all of that is being transferred through the liquid up to piston, up to the second piston with the load on it, right? The one you want to lift. If we rearrange this formula, right, the question is how much force are experienced over here at the second piston. So right,
We're
piston
gonna
number
make that the
two,
subject.
yeah. So P equals to F upon A, right? That means F equals to P into A,
Yeah.
right?
Yeah.
Now the pressure, do we know the pressure? Yes. And so you substitute that, right? So the pressure is the same in the system, right? The pressure is not changing. So how much force will you experience at piston number two? So the force, so let's call this F2, right? It's capital F and small f, but right. So equals to, you substitute this. So small f upon small a into capital A. Okay. Rearrange this slightly, and what you get is F2 equals to F, so the smaller force that you applied on the smaller piston, multiplied by, this is the area of larger piston, this is the area of
Smaller person.
smaller piston. And so basically what's happening, because area of the larger piston is greater than the area of the smaller piston, obviously, right?
Yeah.
And so, right, what's happening over here is what's called a multiplier effect. How is it a multiplier effect? For example, you applied a force of 100 newton. So small f equals to 100 newton, right? Small a, for example, is, right, 4 meters
50.
squared. And large A, for example, is 25 meters squared. For example, I'm just giving random numbers. Okay?
Okay.
Or let's take it as a, right, yeah, let's work with this. So the question is, how much will F2 be, right? And so the larger F, right, for piston 2 equals to 100 multiplied by 25 over 4. And 25 over 4 is
That will.
6.25,
Okay.
right? So 100 into 6.25.
It will give us 625.
625 newtons of
Mm.
force.
Yeah.
So 100 newtons of the smaller piston is actually producing 6.25 times that force. So that's why it's called the multiplier,
Oh, okay.
right?
Okay.
The multiplier effect depends on this part, the capital A over the small a, the larger area divided by the smaller area. The larger area is the area for piston 2, the smaller area is the area for piston 1. Piston 1 is the one that you are applying force to. Piston 2 is the one that is lifting the load.
So pistol one will be like 6.25, right?
Piston 1 is not 6.25. The force you are applying at piston 1 is
It's
100 newton.
acha, okay.
The area of piston 1 is 4 meters squared.
Yeah.
The area of piston 2 is 25 meters squared.
Yeah.
Okay?
Yeah.
The pressure at piston 1 is, right, 100 divided by 4, but we're not calculating that out.
Yeah. Yeah.
Okay? The pressure at piston 2 is whatever force over there divided by the larger area, right?
Yeah.
The pressure is the same through the system, so we substitute, right, the pressure, the formula for pressure at piston 1 over here in the formula. We get this.
Yeah.
We rearrange it slightly. Instead of F upon A, we do F multiplied by capital A over
Yeah.
small a. It's,
Yeah.
it's, it's the same thing, right? It's just a
Yeah.
different way of writing. And so, right, this gives a multiplier effect. Why? Because whatever the result of this, right, is obviously going to be greater than 1. Why is it going to be greater than 1? Because the area of piston 2 is more than the area of piston 1.
Yeah. Okay.
So if the denominator is smaller than the numerator, your answer is going to be greater than 1, right?
Okay.
Like we had over here, 6.25. And so that will multiply with the force that you put in at the small piston. And so, right, you're getting 6.25 times the force, or by putting in 100 newtons, you're getting 625 newtons to lift the load.
Okay.
Does that make sense?
Yeah.
Okay. So that is the concept of hydraulic machines,
Uh. Okay.
right? And
Yeah.
then they give some other examples of a hydraulic jack and hydraulic car brake, so you can read that, right? There's no calculation involved. It's just, telling you how they work. It's the same system, right? For example, in car brakes, you have that small pedal which you press with your foot, but there's an entire system of brake liquids, and that pressure. So obviously, the pressure applying with the foot is less, but then it travels through the system and is applied on wider pistons. Uh, it's applied on wider pistons to cause to bring the car to a stop, or it's applied on more pistons if not wider. So in a car, it's applied on 4 pistons, right? Sorry, 8 of them, 2 at each wheel. Okay,
Okay.
nothing technical over there. Finally, we have, right, the expression for liquid pressure. So how do we calculate pressures in a liquid? And this is part of the extended syllabus for IGCSE. It is part of the syllabus for O Level. Okay, and so, right, you need to follow along over here because there's some manipulation of formula that are going on.
Yeah.
So we talked about the pressure of a liquid increasing with its height or depth, actually,
Yeah.
right? And
Yeah.
so how this works is, right, for a certain liquid at a certain depth, first of all, what they're talking about is they're talking about the volume of the liquid. So what is the volume of a liquid at a certain depth? Right, so we know volume is, for example, length into breadth into height. Right? So let's say, right, this, assume this is three-dimensional, right? And so this is the base of whatever liquid you're measuring, right? For example, in the, right, this is the seabed, and so this and this, right, is length into breadth, and that will give you area, right? And then you factor in the height, and that will give you volume,
Yeah.
right? So
Yeah.
the volume of a liquid is the area, so right, multiplied by delta H for height, right? So the, why is it delta H? Because the deeper you go, the more height, right? The more depth, in fact, shouldn't use the term height, but the more depth,
Okay.
okay? And
Yeah.
that's why we're using delta H. So volume of a liquid is delta H times the area, right? Or to say it, uh, delta H multiplied by A. A is for area, okay?
Okay. Yeah.
Now, that is the volume of the liquid. How are they coming, right? So this is how they're coming to the expression through steps. Next, we know, right, that density is mass upon volume. Density equals to mass divided by volume. And that would mean, right, mass equals to density multiplied by volume. Yes?
Yeah.
Are you following along?
Yeah.
Okay. What would that give us? That would mean that the mass of a liquid equals to, right, rho, that was a symbol for testing, not testing, density,
Yeah.
right, delta H A, right, that's the volume, plugged it in. So that's the mass of a liquid.
Okay.
What's the weight of the liquid? Right? Weight of the liquid column is, right, so mass m, so m into g, right? Mass times gravity,
Yeah.
right? Which means it becomes rho delta h a multiplied by g.
Okay. Yeah.
Following?
Yeah. Yeah.
Right?
Yeah.
That means, right, weight is a force. So we can rewrite this as force, right, of
Mm-hmm.
liquid on area, right? So this area A equals to rho delta H A G. Okay, so it's the same thing. We're just calling, right, weight is the force acting
Yeah.
on, right? Now, here's the interesting thing. What's the formula for pressure?
P equals to.
No, no, what's the formula of pressure? We know
It was force over area.
exactly. Force divided by area. So that means density, that's rho delta H A G divided by again the area. So,
Oh. Okay.
so the
Okay.
area exits the equation.
Yeah.
And so what you're left with, right,
Rho
is,
delta H G.
well, they write it like this: rho G delta H. Rho GH. Right, so pressure of a liquid. You see
It's
where
just
you
one thing leads to another.
and you see how all of these are interconnected, and you can, substitute one into the other and get to a workable
Yeah.
formula. This is
Yeah.
actually the fun part.
Yeah.
Okay,
Yeah.
so what's the formula for pressure for liquid? Rho GH, where rho is the density, right?
Yeah.
G is the acceleration due to gravity, and H is the height of the column of liquid. So density of liquid, height of column of liquid, and acceleration due to gravity.
Gravitation. Okay.
And yeah, and we're done.
That's it.
That's it.
But that was interesting so far.
That was fun, wasn't it?
Yeah.
Right? Now again, right? For this talk, for the liquid finds its own level, I'll look up and a suitable video, and I'll share the
Mm-hmm.
link. Unfortunately,
Okay.
I didn't have that ready for this class. So
Okay.
okay, but you
Yeah.
can also look it up on your own if you like, you're interested. And yeah, so we're done with pressure, and we are done with unit 1 of your syllabus. So next week we will begin with unit 2, which is thermal physics.
Okay.
Any questions?
Nope.
Right, a milestone and achievement today,
Yeah.
right? And ending on a high note because this is interesting, but it's given in your text. Read that, go over it again as well, so you can wrap your head around it. How did they get
Yeah.
from, starting with the volume going to pressure? How did they get
Yeah.
that? Okay,
Okay.
and I'll see you next week, inshallah.
Inshallah.